Okay, so today you should have taken quiz 9.2. We're going to correct assignment number 1, and then we're going to design an experiment. So let's go ahead and get your assignments out. Pass it. Okay, I do need your attention up front because this is going to take a minute for you to understand, and if you're not listening, you won't understand. First thing first, front row gets goggles. Okay. No, different one this time. This has to do with the lab. You guys will actually be able to do these next time. Okay. So what we're going to be doing is we've got to design a lab. That's one of the state core requirements is you have to design a lab. So I'm going to show you 3 experiments today, and you're going to choose with your lab partner which one you're going to do and how you're going to adjust it. Javier, you're actually up here on the front row. Right here in the front, okay? So when we start doing stuff, you're going to have to move up and talk to your partner, okay? So we're going to be designing this. Let's see, we have one other partner that's not here. Actually, we have 2. Nope, just, okay, so there's 3 singlets right here. You guys get together. So when we start doing this, move together because you're going to have to talk and discuss. I'm going to show you each one of these experiments. I'm going to have you talk to your partner about what do you think you could change. Could you change the concentration in this one? Could you change the particle size in this one? Could you change the temperature in this one? And I'll be giving you examples and telling you what you can and can't do. You just have to listen carefully. Okay? Your job is, oh, I went too far. I'm not at the very bottom. Let me stop this for a second and bring the lab. Read it with me. Follow through with me, please. Okay, background. Rates are measured change that occur within intervals of time. For example, if you travel to a city 300 miles away and it took you 5 hours, your rate of travel would be 60 miles per hour. You take the 300, divide it by the 5. Instead of units of length, miles and hour, our time in hours, reaction rates are usually used in moles or grams per time. An example, and I already did this, but we might change it, decide what is different. An example of units on a rate would be a small sheet of metal containing a mole of iron might rust at a rate of 0.5 watt. So if we look at what iron is, it's 55.845 grams. That's about equal to about 56 paper clips. Okay, so you can get an idea about how much it is. 0.5, think of iron. How fast does it rust? Years, weeks, months, days, hours, what? Hours. I got hours, I got months, I got years.
Depends on what's reacting with it.
Well, what's reacting with it is the water from the air.
Well, like, water from the air. I see years. If I get rain for one day, the next day is going to be crusty.
Right. Okay, so she's saying if it's rainy. So say we don't worry about the rain, we just have it in a classroom. How long is it going to take for it to rust? Okay, so would you put here moles or grams per whatever you think it is? Okay, because we've got a little bit of discussion going here, so however you feel like it needs to be, put some kind of unit. So you're going to go moles divided by or grams divided by, huh? It is, because we'd have to test it under different conditions, right? Because we all talked about different conditions. So whatever conditions you think in your mind would work, then tell me what's going on. Okay? All right, so pre-lab. Like I said, we're going to go through 3 different experiments. Yeah, as a lab partnership, you will design and investigate a series of experiments that will investigate factors on how fast reactions occur, the reaction rate. For an experiment, the dependent variable will be the time. Dependent variable will be the time. The independent variable is what you're changing. Okay, so whatever you're changing. Okay, would you get by your partners? You're going to need to get by your partners at this point. So maybe, let's see, let's have you 2 shift over and have a singlet come and back. Is that okay? So we can sit all of you 3 together. They're working together. And Javier, come on up. Or you're going to go back, okay? You don't want him to move? Come on. That was nice. All right. Yeah, you don't need goggles if you're not going to be on the front row. Okay, so look at the bottom right-hand corner of your paper. Okay, bottom right-hand corner of your paper. You see it? You have concentration, particle size, and temperature. We're going to be going through the experiments A, B, and C. If you think it can go for concentration, particle size, and temperature, I would put A underneath all of them. If I just think it would go for these two, I put these two. Do you see how it works? So when we get done, you and your partner are going to decide, okay, which one of these are we going to do for concentration? Which one are we going to do for particle size? Which one are we going to do for temperature? Because you got to use each one of these experiments. Okay, you can't use one experiment to test all of them. So you got to use each one of these experiments. Okay, so the first experiment I'm going to show you here in just a second is reacting sulfuric acid with sodium sulfite. When we do that, we get sulfur dioxide. And we're going to use an indicator to show a change, because the indicator will react with it. It'll start green and then turn red or orange red. We're going to do it in a petri dish. I'm going to go through what you're going to do. But basically, this diagram is on your paper, so it helps you remember. You have to put a reference indicator on the lid and inside. That's the first thing you're going to do. The second thing you're going to do is you're going to put the sodium sulfite and sulfuric acid opposite the indicator and on top of each other. So if I'm testing temperature, I can use one of these ice cream bucket lids, and I can put some ice on it, and I can set my petri dish on it. I can fill this with lukewarm or cool water and set it in. I can do it at room temperature. I can fill it with hot water. Okay, so I can change the temperature. Concentration. If I were to change concentration on this one, I would need to change the number of each of these drops, but I have to have the same number overall. So I could use 6 drops, use 1 drop of one, 5 drops of the other, 2 drops of one, 3 drops of the other, 2 drops and 3 drops, and 1 and 1, or 1 and 5. Okay, so that would change concentration. What about particle size? Can I change the particle size on this one? Okay, so we've talked about where they need to go on the bottom left or bottom right of your paper. So if you put them there, we're going to go through each one of these, and I'm going to show you. On the next experiment, we put down where we could use it, right? Concentration, particle size, or temperature, right? That was A. No. Which one did I tell you you can't use on the last one? Particle size. So particle size does not work for A. Okay, so we're going to talk about this one, magnesium ribbon and hydrochloric acid. This is the only one that I have not given you the reaction for. The others I gave you the reaction for, because you can write the reaction for this one, right? What is it? Magnesium is what? Mg plus hydrochloric acid is what? This is a single displacement reaction. Magnesium gets getting kicked out by hydrogen. So what's going to happen on the other side? Mg has a +2 charge and Cl has a -1 charge. So how many do I need? Cl2 plus hydrogen gets kicked out by itself, but it's a member of Braun-Hifkel. H2. Now I need to balance it. What do I need to do to balance it? Good. If it were me, I would be writing this down under B. Because then you don't have to do it on yourself. Just at the very front, underneath B, the very top, there's this picture, just like this, and you'd write it underneath it. Okay, so what we're going to do is, let's see what we can figure out will work for this one. So I'm using hydrochloric acid, I've got distilled water I can use, I've got magnesium, and I'm going to react those. So I can vary the concentration of hydrochloric acid by adding distilled water to it, but I still have to have the same number of drops in the well, because we're going to be using a well plate. So if I decide 30 drops, I can put 30 drops of HCl. Then I could do 20 drops of HCl and 5 drops of water, and 20 drops of HCl and 10 drops of water. And I can do 15 drops of water and 15 drops of hydrochloric acid. I would not go below half, or you're going to be waiting there forever for it to react. Okay? In fact, I probably wouldn't even get close to half. So I would probably just go down by 2s. Does that make sense? If I was doing 30, but if you do 40, you can go down by 5s. Okay? So we can also, that's concentration, so we can change the concentration. Particle size. You're going to be given a piece of magnesium ribbon. You're going to have to divide it into 4 equal parts. Can I take each of those parts and make them smaller particles? Yeah, you can take some scissors and cut the fourth in half. You can cut the fourth in thirds. You can take and cut it down. So you can use that for particle size. What about temperature? How? Same way we did the Petri dish. So the ice on the ice cream lid, or the cool or water or hot water. Okay, so let's actually look at this one and see what happens. Okay, the last one is the one that's a favorite of all the kids. Shh. This is a favorite of all the kids. This one is, we're doing seltzer tablets in film canisters. This one has to be done outside. I hate to say this, we're doing it Friday and it's supposed to storm, so wear something you can wear outside for about 15 minutes. Okay, so on Friday. It's supposed to storm on Friday, so make sure you're wearing something you can wear outside for about 15 minutes if it's storming. The best place to do this outside is on the mow strips right in front of the bricks. We're hoping they're available at that time if they're snowing. So we'll see what happens. On this one, we're reacting citric acid aspirin with water. Okay, it's actually a little bit more stuff than that, but we're just going to take that general equation. And this is basically what it does. It gives off CO2. As the CO2 builds up, then it makes the film canister explode. What you're going to be doing is you'll get one set of tablets. There's 2 tablets in a packet. If it were me, I would break it into 4s because all you need is about a 1/4 to make it work. Okay. You could take each of these 4 pieces and break it down. So I could do a full 1/4. I could take the 1/4 and break it in half. I could take another one and break it as much as I can with my hands. I could take another one with mortar and pestle and powder it. Okay, so I could do different things with the particle size. This one's probably easiest for particle size. I could do different temperatures. Here's a warning on the temperatures. Do not use ice. If you use ice, you will be there forever. Okay? You can, let's see, particle size. Concentration doesn't really work with this one. Okay, so don't put it under concentration. Doesn't really work with this one. Okay, let's try this one then. I'm going to do it over here. I'll show you what I'm doing. You'll be given, okay, so on this one, this is the only one that you're going to need to have 2 graphs for. You're going to have to graph one with time and one with the number of bricks high it gets. Okay, so whoever's doing the timing has got to stand back and watch for when it explodes. The other one is watching for how high it goes. Okay, and if both of you can get how high it goes and stop a timer at the same time, great, because then you can compare. Okay? That's why we need to go outside. Now, I sort of set up one of them for you. Let's erase this and go through it together. I forgot to erase it last time. Okay, so what I need you to do right now, before we start this, okay, I'm waiting for your attention. Okay, on the second page, if you turn the page over, it says, what reaction, A, B, or C, did you choose for the test? I need you to take a minute, talk to your partner, decide what you're going to use for concentration, particle size, and temperature. Go. How much longer are you going to crutches? How much more do they think it's going to be? Oh, that's painful. I'm sorry. It's not fun. Okay, bring it back up. We're going to talk about setting up your first one. So whatever one you picked, hopefully you got to talk to the people around you and see if they chose the same stuff or not, because that's what the question number 2 is. Go ahead and flip to the next page. The next page is where you're going to set up the lab. Whenever you're ready. Thank you. Okay, this is where you're going to set up the labs. So whatever you chose for concentration, and it doesn't mean what I'm doing up here is good, bad, or ugly. You can use any of the ones that we talked about for concentration. That's your choice. Okay, so the first thing you want to do is from the front page, get the balanced equation for whatever you chose for concentration and write it down there. So do that first. One for each thing. So what experiment are you going to use to do concentration? You just can choose one. Nope, you can choose one. You're going to do all 3 experiments, but you're going to choose one for temperature, one for concentration, and one for particle size. Okay, you got your equation written? You have your partner help you, and you can use their paper as your, and then switch. Let me see if I can get this. It looks like it's stopped bleeding finally. Just put a Band-Aid on it. Don't pick up glass. I know better than that. Broken glass. Evidently, I don't know better than that. Yes, sir. Okay.
Oh, we just put which one we put for the concentration. So
Yeah,
A.
A. So you put A's concentration. A's lab. Or balanced threshold. Okay, now the next part, has everybody got their equation written down? Okay, how many chose the Petri dish? A. How many chose A for concentration? How many chose B for concentration? Okay, so anybody chose C? Good. Nobody chose C. That's good, because you can't do C with it. Okay, so you've written your equation in here, right? The problem is really easy. All you got to do is look at what's at the top of the page and say, oh, how does concentration affect reaction rate? Yep, you're going to write that down. I shortcutted reaction rate because I ran out of room. Yeah. That's why when you go to the doctor or get something from the pharmacy, it's RX.
It's not even RX. It's just...
Well, when they have a thing on your prescription that says RX.
I thought there was...
Nope, RX. Okay, so let's look at the next one. Hypothesis. What do you think is going to happen? Write it down. Write it down. As you get more concentrated, what happens? Or as you get less concentrated, what happens? Tell me. Go. No, just concentration. Right here. So when we get to the page that's for particle size, we're going to use that equation for particle size. Then talk about it. So each of these are just for one thing. So here we're doing just concentration. So we're not varying particle size, we're not varying temperature. We're just doing one. Okay? All right, so you've written your hypothesis. Okay, what are you varying? What is changing? That's your independent variable. What are you going to change in your experiment to change the concentration? Of what, though? So if you were using the well plates, it would be the hydrochloric acid and the water. If you were doing the Petri dishes, what would it be? What are the 2 chemicals? Sodium sulfite and sulfuric acid. Those are the 2 that you'd vary. Okay? And what's always going to change? What's the dependent variable? What are we looking at? Time. And whatever else is constant. So the well plate, I'm not going to change the well plate. I'm not going to change the total amount of water, or I'm not going to change the petri dish. I'm not going to change the amount of universal indicator. I'm not going to change whatever, okay? Whatever's not changing. I'm not changing temperature. Those are constants. Universal indicator. Sulfuric acid and sodium sulfite. Okay, so everybody's got the first thing done, right?
No.
Independent variable is the thing you change. What are you changing? So concentration of hydrochloric acid by using hydrochloric acid and water, or sodium sulfite and sulfuric acid. What? Amount of each. Green stuff is universal indicator. Yes. Say it really loud. Dependent variable is always time. Yes.
Okay, what's the molarity?
Molarity is what you'll get when you go back to lab, and it will be on the bottle. That's the concentration. Okay, so let's talk about the procedure. You need to write the procedure in a way that you could hand it to anyone else in this class and they would know what to do. Okay? So before I write the procedure ever, I set up a data table. What do I want to know? Okay? First thing, you're going to put trial. And put 1, 2, 3, 4. This is your x-axis on your graph. That's your x-axis. So down here I'm going to put trial number 1, 2, 3, 4. Okay? Then, most of you are doing the petri dish, so let's talk about that. But those of you that are doing the well plate, you're going to do the same kind of thing, just different chemicals at the top. So for the well plate, or for the petri dish, we're using H2SO4 and we're using Na2SO3. Okay? The best probably thing to do here is probably use 6 as an overall amount. So I would start with 1 and 5, 2 and 3, 3 and 3 and 4 and 2. Huh?
2 and 4?
2 and 4, yes, thank you. Okay, so I've got some on either side. Now you could start with a 2 and 4, 3 and 3, 5 and 2, and then go 5 and 1. I don't care. You can do it however you want. Okay? As long as those add up to 6. Now if you're doing the well plates, you want it to add up, those two to add up to 30 or 40. Okay? And you don't want to go below half of each of them. Okay, remember I talked about that? Okay, so you're going to set it up the same way. You're just going to have, this one you'll have hydrochloric acid, and this one you have distilled water. And you'll just have, start with full strength, 40 drops or 30 drops, whatever you're going to do, 0. Then 38, 2. Okay, something like that. What do you think the last column is going to be? Time. I need something to time. Now, let's go back to the, oh, by the way, time is your y-axis. So I'm just going to put time here so I remember that it's my y-axis. I'm not going to put numbers because I don't know how much time it's going to take yet. So I don't know how to make it. Seconds. Yeah, you should be doing seconds. Okay, but if it takes really long time, do you want to change it to minutes? Yeah, probably. Okay, so sort of look and see how long your reaction takes. Most of these that we did up here at full strength just took seconds, right? And then you could see it. Okay, so number 1. On number 1, you want to write down what is all the equipment you need. All the chemicals, all the equipments. Write it now. Gather. Tell me everything to gather for your experiment. On number 1. Tell me everything to gather for number 1. Solutions. If you're using this one, yeah, I would use solutions. You need like a petri dish. You need universal indicator, sodium sulfite, and sulfuric acid. If you're using the well plate, you need the well plate, magnesium, hydrochloric acid, and water. Indicator. Yes? You need a well plate, you need hydrochloric acid, water, and magnesium. That's it. Yes? Hypothesis is, what do you think is going to happen when you change the concentration? Okay, is it going to go faster? Is it going to go slower? Because we're all about time right now. So as I get more concentrated, is it going to go faster? If I get less concentrated, it's going to get... Okay? All right, so this is all about what to gather. I'm just going to put a generic thing here so you can sort of know what to do. Okay, then what you want to do is set it up. So tell them how to set it up. So if I've got the Petri dish, what was the first thing I did?
Make sure it's clean.
Made sure it's clean. How did I do that? Drop of indicator, a universal indicator into the Petri dish. If it changed colors, I got to clean it. If it didn't, then I can keep going. On the well plates, what did I do? What was the first step? We gathered the materials, but what would be the next step? Sorry. You need to cut your magnesium ribbon into equal sections. Okay, so 4 equal sections. Okay, so Petri dish people, after you've done that indicator, and if the indicator changed colors, you wash it and put the indicator back in to make sure it didn't change. Where else did I put the indicator? On the lid. So now tell me to put it on the lid. 1 drop of indicator on the lid of the Petri dish. Magnesium people, after you got them in 4 equal parts, what do you think you want to do? Okay, I want to go back up to my data table. It says, as per data table, add drops of hydrochloric acid and water for trial 1. Write it. So that would be step 3 for you guys, I think. So you would add drops of hydrochloric acid and water according to data table for trial 1 to a well. Okay, next step, Petri dishes. What do we do?
Wait, after what?
So we did the universal indicator. What do we do next?
So now you do 1 drop of H2SO4.
Yeah, it doesn't really matter. I like to leave the H2SO4 to last because it's one that's easy to squeeze. These are a little bit harder to squeeze, so it's harder to get the drops out, and you got to do it fast. So I put the sodium sulfite in first. So what I would do is say, put sodium sulfite in according to data table for trial 1. Opposite the universal indicator, because it was opposite in the Petri dish, right? I wanted it on the other side, not on top of the indicator, and not just anywhere generic. I need to tell them where. Whatever step you're on. I don't know what I'm on in each one. Okay, for the hydrochloric acid, what do you think we do next? We're going to add drop. Did we add drops? We already added drops to the well plate, right? Okay, so now you're going to put the magnesium ribbon in the well plate and time it. And then you can say repeat for steps, whatever to whatever, for trials 2, 3, 4. Okay, on the next one, here, guys, we've put the sodium sulfite in according to the data table, opposite the universal indicator in the Petri dish. So make sure you put that opposite of the, because they got to know where to do it. If you hand it to somebody, they're not going to know where to put that drop. You saw it, but they didn't. So add on here, opposite the universal indicator in Petri dish. And if you run out of room and your steps are off, just cross them out, give yourself some extra room. The sodium sulfite, opposite the universal indicator. Not yet. What do we have to do to make the reaction happen? So the next step is to add sulfuric acid on top of the sodium sulfite in the Petri dish according to the data table for trial 1. Yes?
So on our step, we were
So into well plate, and then you're going to say time it. Time the reaction and record. Time. Then you're going to say repeat for trials 2, 3, 4 from steps, whatever you need to. Look up and see where you need to start again for the next trial and go down.
You have to wash the dish again?
Okay, so let's keep going. Yeah, for them they don't because they've got many wells, but we're going to have to. Okay, let's go back to the Petri dish one. Okay, so what did you do? What do you need to do really fast now? Put the lid on so that you can see both universal indicators. Okay, and time. So put the lid on and time till the color of the universal indicator changes. And you and your partner decided when you're going to decide when that's the end. So you got to put that down. Is it totally orange or first appearance of orange or a ring of orange? You decide. Okay? So you're going to time and record. Don't forget to say record because you'll forget. Okay? Then what do we need to do when it's done? Wash it with soap and water, dry completely, and then you can say on the next one, repeat for trials 2, 3, 4 from steps, whatever you need to repeat from. Okay? All right. So you're going to do this for the other two. I helped you through concentration so you sort of see what you need to write down. You're going to do temperature and you're going to do particle size. Remember that I'm pushing you to write exactly what you need to do. Don't assume anything. You know what assume means, right? Yeah, okay. Yes?
What is molarity?
Molarity you're going to get off the bottle in the back when you go back to the lab next time. Okay, any questions? This is done. If you got it done and you said repeat for trials 2 and 4 from numbers, whatever, then you're ready to roll. Okay, so time is yours. Work on the others. You don't have to fill all 9. You can use less. You can use more if you need to. Okay? When you're done, you need to clear that with me before you're allowed in lab next time. Yes? Let me turn off this real quick.